Right, class. Apart from supplying organic materials, these mulching also helps in as a buffer in soil temperature, as I explained earlier, because it's maintained the soil temperature. It's don't allow that direct sunlight hit the soil, preventing soil compaction. And also it minimizes erosion. Why it can minimize erosion? Because of direct, they protect the soil from heating from direct water raindrops. Right. Okay, these are some of other maintenance methods where we should apply or where we should use mulchings. This one you can see from the slides, not so important. Basically for agriculture, yes, we use mulching. For aquaculture, sometimes we use at the edges of the ponds to avoid erosion, and also to maintain the temperature of the surrounding of ponds. Here drainage, there are the importance of drainage. We have underground water table, upper ground water tables. So I think it's not so important for your level. I just keep it. It's not so, no need to worry about this. Okay, this is the most important thing when you study about soil drainage. Okay, soil drainage classes. The drainage class of soil define the frequency of soil wetness and limits the agriculture practices. Normally for planting crops, right? Yes, we have to monitor, we have to check the soil drainage. Okay, if you see the picture here, there are 4 types of soil. Okay, if the soil is well drained, you can see the depth of water movement up to sea horizon. The depth of gray colors, if you notice in your chapter 1, when we study about soil horizons, there are one of the chart that I put in the notes. It shows the different colors. If the better the soil drainage, the depth of the gray color is deeper. It shows that the organic materials are good beneath the B layers. Similar to that soil that you test in the pond that day, when you took the soil sample from beneath the pond, it's the color of the soil beneath the pond is gray in color. A similar situation here. If the soil is well drained, the soil will be grayish in color. That's why alluvial soils usually gray in color. Moderately well. If moderately well means the gray color of the soil will be up to B layers. And somewhat poorly in between A, and if poorly drained means you cannot see the grayish color in the soil horizon, in the soil profile. Okay, each of the soil profile here, they have the depth level there. Depth level there, korang boleh check back at chapter 1. For example, if you notice the A horizon about 1 feet. 1 feet means from 2 to 10 cm. Yes, according to the soil horizon. Normally A horizon is about 1 feet. B horizon is up to 3 feet. 3 feet here means 90 cm. 1 feet is 30 cm. So if 3 feet means up to 90 cm. The sea horizon about 4 feet and beneath the soil. These soil horizons you can find in chapter 1. So if poorly drained means you even cannot notice the green color layers at your A horizon. That means 1 feet. No, not 1 feet height. That is very poorly drained soils. These are the soil drainage classes as defined by USDA and NRCS. Okay, in this slide, it shows the characteristics of well-drained up to very poorly drained soil and its effect on croppings. Usually, if the drainage is not properly managed or not well managed, it will affect in terms of the root growth, the root movements in the soil. If the soil is well drained, you will lose water from the top of the soil. So we need proper irrigation. Proper irrigation here means we need to supply water. Well drained, that one is excessively drained. So rarely we lose the water from the top of the soil. Normally, what we say, the sandy soils. So if well drained, water is removed readily, but not rapidly. That means you can't, in order to have drainage or irrigation water supplies. Otherwise, for moderately well drained up to very poorly drained soils, if you want to cultivate the soil, you need to have, you need to modify the drainage system and also the irrigation system. If very poorly drained means the water will stay in the top of the. Okay, as I explained just now, for poorly drained, very poorly drained, and somewhat poorly drained, the water will stay on top of the soil. So we have to supplement the drainage to remove the water, especially at peat areas. That's peat soil. This is a problem with peat soil. You have to maintain the drainage level. The water level, we call it water level up to 25 cm in peat areas. Okay, for this one, this is a simple comparison of two shapes. Now we can do soil ditching or field ditching or drainage in two methods. That is, the first one is V shape and the second one is W shape. Okay, and you can see the W shape here, the nodes both are V shape. You can see the V shape here, top of we call it as V shape. If W shape means 1V, we have dish, another drainage. So the one we call it as W dish. Both the differences between both the system is if single W water, if double more water in the field. Normally at peat areas we will build for the V, the upper stream we will build W shape to manage the water level. Okay, these are the general rules for us to build a drainage system. It must have outlet, lateral field ditches. Field ditches is the one have V shape. If lateral and also outlet ditches will be W shape, and outlet will be bigger in size. What is carried to the outlet channel by lateral ditches, which receive water from field ditches, or sometimes from surface of the field. Let's see what yes. This is the picture setup of drainage system in fields. People from Malaysia, you can find this type of layout, drainage layout in plantation areas, in oil palm fields. Yes, whatever soil type, whether it's mineral soil or it's peat soil, you will have the drainage system, the boundary of the field will have water. This is for in case you have excess of water, you can to remove the water from the field, you have to use this drainage system. Or in case during dry season, you have to fill up your field with water. So in order to do that in an economical way, you need a proper drainage system. Okay, this is the benefit of drainage already explained just now. Alright, this is the last part of the slide. And of course, the proper drainage will reduce erosion, will reduce water compaction. All of these you can find at peat areas. Peat areas it hold water, and also it can lose water very easily. And once it loses water, the soil becomes compact. As I explained in the previous class, when I explained about bulk density and also particle density. Bulk density contains more spaces, macropores and micropores. When you compact the soil, you lose all the macro and micropores. So you only have the particles. Similar here to the peat soil. Okay, class. If you have any questions or any doubt about the video, you can comment on the comment section, or you can comment and meet me. Alright, thank you, class. Have a nice day.